Hello student, welcome to my channel that is Soil and Land Management. This is your Professor Dr. Vaibhav Pandit, working as assistant professor in School of Agriculture SR University, Warangal, Telangana. Today I came to discuss about the major issue of the soil India, that is the soil erosion. So what is soil erosion? Soil erosion is the process of transportation of the soil from one area to another area by the different agencies like water, wind, ice, or the gravity. So here are the three general process for the soil erosion. One is the detachment, then transportation, and the deposition. So mostly through the soil erosion, there is the loss of the top fertile soil. If the top fertile soil will get eroded, then the water, the nutrient present in the soil will also get lost. Because of that, the soil fertility and the agriculture productivity will get reduced. So if you'll see the annual soil erosion rate in India, that is nearly 16.35 tons per hectare per annum, which means that 5,334 million tons per year for a country. Due to soil erosion, there are 74 million tons of essentially nutrient get eroded annually. Because of that, then we will get the economical loss of nearly $68 billion per year in India. So there are different effects of soil erosions. If you'll see, there are two types of effects. We will categorize the effects of soil erosion. One is the on-site effects and another is the off-site effect. In on-site effect, we will consider that the what is happening in the soil due to the erosion. So the soil will get lost, means we know that the fertile soil will get eroded. The soil productivity will reduce. If the soil productivity will reduce, it means that what are the essential element will be there, or microorganisms there essential, which is required for the decomposition of organic matter, also will get reduced. So it will have the negative impact on the crop yield, and the crop yield will get reduced. If you see the upside effect of soil erosion, one is the degradation of the water quality. Whatever the freshwater reservoir lake will be there, if the eroded material will get deposit into the that lake and water, the water quality will change. It means it will get bad, poor quality of water. Then the sedimentation of the silt into the stream and reservoir, so that what are the um, storage capacity of the stream and reservoir will get reduced. That is the offset effect. In India, if you see the soil erosion status by the NBSS and LOP, the soil erosion in million hectare are 146.82 million hectare area under the soil erosion. These are the different agencies which is work on the land degradation and also the soil erosion. So these agencies will do the survey and calculate how much area of soil eroded present in the India. So recently the NBSS LOP in 2004 they have done the survey. They have observed that nearly 146.82 million hectares soils are eroded, with that much area under erosion. So there are the different types of soil erosion. One is the geological erosion, another one is the accelerated erosion, or we can say the man-made erosion. So geologically, if you consider that will occur due to the natural processes. So the rate of the soil erosion by this process is very slow, and the erosion also is limited. So whatever the erosion will occur, that one will get balanced or balanced by the soil formation processes. So that this types of erosion which is not harmful to the agriculture. So only the small amount of soil get eroded, and that amount of soil will get formed by the soil forming factors. So in this erosion, the human interference will be nothing. So whatever the erosion will occur, that will occur by the natural processes like the high rainfall or the topography, or there is no vegetation. This factor will be there for the geological erosion. So there is a this is also called the normal erosion because the rate of the erosion is very less. Another type is that is accelerated erosion. So this is occur due to the interference of the humans. So the major factor responsible for the accelerated erosion is deforestation, overgrazing, and improper farmer practices, construction or mining. So in this erosion, the rate of soil loss is higher compared to the uh, normal erosion process. So because of this process, the soil fertility get degraded and the land degradation will also occur. This erosion is very harmful for the agriculture because of this erosion. So whatever the soil get formed and it will get eroded by the different factors, and the soil loss is more in this erosion as compared to the soil formation. That's why it's very harmful, and what are the nutrient present in the soil will get eroded, so it will have a negative impact on the agriculture. Then what are the causes or factor which is responsible for the soil erosion? So we will categorize into the two factors, that is natural factors, or we can say natural causes, or the man-made or causes. So first one is the water. If the higher rainfall is there, then higher rainfall will break the soil aggregates and form the crusting and compact soil. That crusty and compact soil will not allow water to infiltrate the soil, or the permeability of that soil will be reduced, so that the runoff will occur. Second factor, that is the wind. If the your soil is dry or there is no vegetation, no moisture in that soil, soil, the soil particle is in loose condition, dry condition, and that particle soil easily we pick up and transport to other location. Another factor, that is the topography. If the slope is more, the velocity of the runoff will increase. That velocity is responsible for then soil erosion. If the slope will increase by 2, the velocity will increase by the 4 times. So that is another factor for the soil erosion. Then most important factor, that is the soil characteristics. In the soil characteristics which is related to the soil erosion, that is the infiltration rate, hydraulic conductivity, and permeability. If this property is good, then will allow the water to infiltrate into soil, so erosion will get reduced. Then another factor, that is the climate. So high rainfall and drought condition, which is responsible by the high erosion risks. So another category, that is human induced causes or human induced factors, that is the deforestation. Deforestation will reduce the vegetation on from the soil, and the soil become exposed to the rain. So when it will come to the rain directly, so it will cause a splash, or soil aggregate will get break, which from the crusting in the soil and will not allow the water to infiltrate in the soil. Another is overgrazing. Because of the overgrazing, water, the vegetation is there, it will reduce. So finally the soil will come in contact to the rain directly or through wind, so it will cause the erosion. Then different agriculture practices like excessive tillage. If the farmers will do the excessive tillage, the organic carbon content in the soil will get reduced, and soil aggregate will get break easily by the first rain. And another factor, that is the flowing along the slope, which also called the tillage erosion. If you do flowing along the slope, what are the implement will use will cause the movement of the particle. If the slope is more, the velocity will increase and the erosion will occur. Then next factor, that is the monocropping. The farmer will take the only one crop year, so that soil fertility will get reduced. Also the organic carbon content will get reduced. So organic carbon content will reduce means soil structure will degrade, and the soil aggregation also will become a weaken. So that factor is responsible for the formation of compact soil and will cause the runoff. So here we will see the water, the soil erosion process, and how it will occur by the wind and water, because water and wind is very important agencies for the soil erosion. First we'll see the water erosion. In water erosion will occur in 4 steps. So first step of water erosion is the flash erosion. In flash erosion, So what are the raindrops will be there bigger size. It will come in the contact of the soil, and it will detach the soil particle. Because of the high kinetic energy of the raindrop, the soil particle will jump into the air up to the 30 centimeter. This is the first stage of the soil erosion. It will break the soil aggregate, separate the soil particle, and it will easily transport from the one location to other location. This flash erosion more severe in the bare and unprotected area because there is the direct contact between the soil and the raindrops. The second important steps in the soil water erosion is the sheet erosion, which mostly occur in the red and the black soil where the uh, topography is there, slight slope is there. So this erosion we cannot see because it will remove the uniform layer. That layer we cannot see, but it's very harmful because we cannot understand if the erosion is occurring or not. The third step is the in a water erosion, that is the real erosion. This is the third stage. So in the real erosion, the small channel will form, and that small channel we can remove or we can manage by the normal tillage practices. Then this real erosion will convert into the gully erosion, where the rills size, depth, or the width will increase. So that one we cannot correct it by the normal tillage practices. So to manage this gully erosion very difficult. Then gully erosion will convert into the ravines. That is a still more difficult to manage by the farmers. So we can see here how flash will occur. Because of this flash, the soil particle will jump into the air and it is separated because of the high kinetic energy of raindrops. In the sheet erosion, the uniform layer, light uniform layer, thin layer will get removed. We cannot see. This is third stage where the small ridge form. The small will take up, uh, that small ridge dimension will increase and it will become more. These are the total fourth stage in the water erosion. The next one is the wind erosion. So wind erosion will occur in three steps. One is the suspension, saltation, and the soil creep. In suspension, there are the soil particle that is 0.1 mm size. The size is less than 0.1 mm, and will get suspended into air and will be away from the ground, will be present in the air and transported from one area to another area. So the contribution of this suspension in a wind erosion, that is nearly 3 to 5%, and the huge amount of soil will get transported by the suspension as compared to saltation and the soil creep. In saltation, the soil particle will be available that is 0.1 to 0.5 mm size, where the particle will bounce on other particle, and that particle will get the kinetic energy and will get moved to the further. So the saltation contribution in the wind erosion, that is nearly 50 to 70%, 50 to 75%. Highest amount of the contribution is that process will cause the more wind erosion, that is the saltation process. Another one is the soil creep. In the soil creep, the bigger size particle will be available, that is the size of that particle will be 0.5 to 2 mm. The particle will move along the ground area due to the wind force. The contribution of the soil creep in a wind erosion, that is 20 to 40%. We will see this area here. The soil particles is in a air in suspension. Then another stage is the whatever the soil particle is, it will get bound. So this particle will get kinetic energy, then it will move, and again it will bounce. So another particle will get energy, it will bounce. When in soil slip, because of some slight slope, so soil get transported. Soil get slide, it will roll. So soil erosion will occur. Then how to measure the soil erosion? What are the different equations are available? So most famous equation, that is Wishmeyer and Smith equation. This is the universal soil loss equation we'll use for the water erosion. So here A is equal to R K S L S C P. A is the average annual soil loss, that is tons per hectare per year. Here is the uh, rainfall erosion factor. That rainfall erosion factor is nothing but the kinetic energy divided by the intensity of the rainfall in 30 minutes. So higher the kinetic energy, higher the intensity, the more the erosion by the water. The second one, the soil erodibility factor. That one will be the soil properties. If the soil infiltration rate or hydraulic conductivity or permeability is high, then the soil erosion will be less. If the infiltration rate, hydraulic conductivity, and the permeability is low, soil erosion will be low. Means the soil is more have ability to get eroded. Then another factor, that is the slope. On 9% slope, we will calculate the water erosion. Then LS is the slope length. We will consider the slope length, that is 30 meter. On 30 meter and 9% slope, we will calculate the soil loss. And C is the crop management factors. What are the cropping system is there? What are the crops are there? Any crop cover is there? This factor will consider. That C is the crop management factor, in that crops will consider. Is the conservation practice, in that what are the mechanical practice we will any mechanical practice we are doing or not, that we will consider. So this is important equation RKSLSCP, that is given by the Wishmeyer and Smith, that is for the water erosion. Then another equation that is given by the Woodruff and Sidoway, that is related to the uh, wind erosion. So is the soil loss due to wind erosion in tons per hectare per year. That is the function of I, K, C, L, and V. So I is the soil erodibility index. So that soil erodibility index depends on what is the aggregation and texture. What is the aggregation and texture? But in the water erosion, the soil erodibility is depends on the properties. That is the infiltration, permeability, and hydraulic conductivity. But here the I, here the soil erodibility index, it depends on the texture and aggregation. If the more aggregation or the fine texture, the soil erodibility is less. If the coarse texture and the individual soil particle or less aggregation, the soil erodibility is high. The key indicator soil roughness. The soil is the fine or smooth, smooth or rough. It also important for the wind study of the wind erosion. Third on the climatic factor. In that we'll consider wind velocity, rainfall, and the temperature. So these are the factor we'll consider to calculate the wind erosion. The L one is the unsheltered field length. What is the distance between the wind blow? What are the shelter is there or unsheltered field is there or shelter field is there? Shelter or unsheltered field means any types of the trees are present or not. V is the vegetation cover. What types of the vegetation is available? Then this equation is given by the Woodruff and Vitosho. So this equation we will use to determine the water erosion and the wind erosion. So, what soil conservation practices we can follow to reduce the soil erosion, to maintain the soil fertility, to improve the agriculture practices. So there are two types of the practices we follow. That is the agronomical practices and the mechanical practices. In agronomical practices, we will focus on only the crops. With the crops, we will define different engineering on the field. This agriculture practice, agronomical practice, effective when the slope length is less than 2%. In that different contour farming we will do. Then strip cropping we will follow. Crop rotation we will do. Then cover cropping and mulching. So we'll see here the counter farming. Here again the slope we will do the farming. The counter is the equal line attached to the equal elevation, that is called the counter. So we'll see this is the counter farming. We'll see all this is again the slope. When we'll do again the slope, the velocity of the water will reduce. This is this will reduce the velocity of water. The more water present in the row, it will get infiltrated into the soil. So water the soil will get eroded from the higher slope. So it will get attached to here middle area between the two planting rows. So that the water the soil particle coming from the higher area will get uh, uh, saturated in the somewhere middle in the field. It will not go up to the end. So this is like one of the barrier we are creating in the middle against the slope. If this is the slope, we have to do the farming or plant in the row against the slope. opposite direction. So it will reduce the runoff, reduce the velocity, will trap the soil water, and also soil water will get the more time for the infiltration. This is the strip cropping. In strip cropping we are going against the slope, but what we are practicing, if the this slightly slope is there, we are practicing alternate uh, water erosion permitting crop and erosion resistant crop. Okay, erosion permitting crops like maize, maize is there. Erosion permitting crop like the soybean is there. Means who will cover the maximum area on the ground, that is the erosion permitting crops. Okay, so the alternate rows will be there. Alternate rows will be there. Growing out different crops alternately in a band along the contours, along against the slope. So water, one row will permit the erosion, other row will trap the eroded soil. Allow the more water to infiltrate into the soil. This we will see here. Alternate alternate strips, erosion permitting and erosion resistance crop. The next one will be the crop rotation. Crop rotation is an important factor to maintain the soil productivity and improve the soil structure. First year, if you are taking the corns like cereals, second time you have legumes, then wheat, then cover crop, all those things. So this will help for the improve the soil fertility. Water the nutrient will get lost by the soil erosion. So this crop rotation will improve the soil fertility. Not only the soil fertility, also what are the pest and disease coming on a monoculture cropping. So that pest and disease cycle we can disturb. So the pest and disease will get attacked, and the weed suppression also will occur. So weed intensity will get reduced. The most important is there, if you follow the crop rotation, the organic content in the soil will increase, and it will be helpful for the uh, good soil structure. If the good soil structure is there, the more water infiltration will occur, more in hydraulic conductivity will occur. So the more water will get infiltrated in soil, the less runoff will occur. Then another one is the crop covers, cover cropping. In the cover cropping, we have to select the those crops which will spread, which have more biomass and cover the more ground area. For example, cowpea is there, or soybean is there, ground is there. That will cover the more area and more surface area on the ground. If the bare land is there, or unprotected land is there, the flash erosion will occur. And here the protected land is there, there is no flash erosion, no uh, sheet erosion will occur. So this protected, or this cover crop will protect the soil from the coming into direct contact with the rainfall. So this will help like this. Another practice, that is the mulching. In mulching we will cover the soil by the crop residue, so the we will reduce the contact between the soil and the rainfall, high intensity rainfall, so the flash erosion and crusting should not form. So you see in this video how the counter cropping is there. This is the counter cropping. Reduce the runoff, conserve the soil moisture, improve the productivity, but it is very less effective in the high slope area. This is the strip cropping, where the alternate strips we are seeing here, alternate strips, which is improve the water infiltration rate. The alternate strips. This is the cover cropping. We cover the maximum area on the ground and avoid the direct contact between the high rainfall soil, and avoid the attachment of soil particles. This is a crop rotation, which is required for soil fertility and increase the organic content and good soil structure. This is a mulching. Also mulching. Here we can see the plastic mulching. Will avoid the direct contact between soil and the high rainfall, high intensity rainfall. We can do mulching by the crop residues, which is improve the soil health and crop productivity. So this practice is help for the soil and improve the productivity of farmers. So another soil conservation practices, that is the mechanical or else we can say engineering practices. This practice will follow when the agronomical practice is not sufficient to manage the soil erosion, and which this practice mostly will follow on the slope which is greater than 2%. Here in this practice we have to construct some physical barriers or structure to trap the soil or reduce the to trap the soil or reduce the velocity of the runoff. The first practice, that is the bunding. Bunding is nothing but the embankment of some structure across the slope so that to intercept the runoff and reduce the velocity. In that different types of bunding is there a counter bunding. It is possible when the slope is less than 6%, which will allow the water to infiltrate, and it's possible in the low rainfall area less than 600. We can this one will do at the border of the field along the counter lines in a trapezoidal shape. Second one is the graded bunding, which will do in the high rainfall area, that is more than 750 rainfall. Is mostly will do in the black soil where the infiltration rate is low. So this graded bunding will allow the water to infiltrate soil. Then is the compartment bunding, where the small rectangular shape the bunds will do. Number of bunds will do, or the soil will divide a number of bunds. In graded bunding also we will follow the many bunds in the field. The counter bunding only the along the borders only will be there. Here in the middle of the field, here the compartment number will increase in the field like this. If that is the slope direction, we will construct the bunds across the slopes to reduce the velocity and runoff, so to increase the infiltration in the soil. The counter bunding will do at the border of the field. The graded bunding will do at the starting, middle, or the end of the field. Here in compartment, there is small rectangular size compartment will do like that. So the water infiltration will occur more. Another practice that one we will follow, that is the terracing. In the terracing we will convert the steep slope soil into the flat step like the platform slopes to reduce the slope uh, length and degree. In that we will consider bench terracing, broad base terracing, and zinc terracing. So bench terracing is effective up to the 33 to 50% slope. It converted the slope area into the field level field. It also includes the inward sloping, that is we will see in the high rainfall area, outward sloping for the low rainfall area, and level sloping, that is the irrigated area. Then broad-based terracing, that is the wide surface channel or embankment will construct in a rolling land with a slope between 30 to 60 3 to 10% slope, which to allow the farm machinery. In zinc terracing, that is will divide the field into two zones. The upper zone will allow the water to get eroded. In lower zone, we will trap that water. This is the terracing. This is the huge slope is there. At 33% slope, the terracing will follow. That terracing we will divide into the different steps. So the steps will become the one field. And the step wise we are constructing. This is the inward slope. Here the slope is there. Middle we will do the trench. Here we will collect the water. This is we will do in the high rainfall area. This is the outward slope, not inside. This is the level slope. This is the broad bed. Here the bed is the higher side. Middle is the row will be there. In that will collect the water. This is zinc terracing. Here the we will allow the erosion and will collect in the lower area. This will do in the 3 to 10% slope. Then trenching. Trenching is nothing but the digging the pit or trenches across the slope to trap the water and sediment. So this is the trenches. We'll dig trenches. In this we will trap the water and air. And this is one of the soil conservation practice also. We'll see in the area and semi regions. So this in that counter trenching will be there. That is the tracker of continuous trenches will made on the counters. Only counter slope that is border for non-arable and forest land to recharge the groundwater and reduce the runoff. This is the continuous and staggered trenches. This continuous trenches there, slope. This continuous and staggered trenches. Then another structure we see that is gully control structure. That is nothing but some physical structure will construct across the gullies to stop the that is increase the size of the gullies. In that the check dam will be there, gabion will be there. The gabion is will do mostly in the black soil. It's in this figure. This is the eroded land is there. This is the gullies are there. Across that gully will construct the one barrier. This is check dam so that the size should not get increased. Size should not get, because it will increase. This soil will get irritated. This soil will get eroded. We have to stop the erosion. In Gavian, so like the structure will do that is a stone structure. So this is stone structure across this line structure across this line, so that this part should not get eroded. This part will not get eroded. So here we will trap the sediments or water. This is most commonly seen in the Uti region of India or the northeast region. So other engineering practice we will follow that is the waterway diversion drainage practice and subsoiling. In waterway drainage practice, these gullies are there. So we have to stabilize these gullies. So the water, the erosion will be there, slope will be there. We have to divert to another direction. So this area do the we have to grow the some greenery or grasses. So the it should not get eroded. This part should not get eroded. Okay. Then the water will get drainage will collect in a one area that is reservoir will store. Okay. Then in subsoiling we'll directly up to subsoil will make a trenches in their water will and the silt will get stored. Then biological practice also there like afforestation and reforestation. There is a need to focus on the afforestation to increase the vegetation cover, which will help for the improve the soil stability, avoid the landsliding. Another practice is land agroforestry. In agroforestry, we are like to grow the trees along with the crops so that you improve the soil fertility and add organic matter contain the soil also the nutrient. That organic content will improve the soil stability, soil structure, infiltration rate, then hydraulic conductivity, and reduce the erosion, and also improve the soil farm productivity. Then grass waterway we have seen just now. Then shelter belt and windbreak. So shelter break will be these are the shelter break means the tree structure across the wind, and windbreak is any structure. It will come in the wall also across the wind. So it will reduce the velocity of the wind. Since this one is the forestry we can do agroforestry that is a plantation of trees and crops on same field. This is what grassland way where we have to do the grass we have to do the grasses along the one drainage channel. This is the shelter belt and the windbreak to reduce the wind velocity and wind direction. Thank you for uh, thank you and please watch this important topics and likes and subscribe.